So, I am Dr. Alfredo Carpinetti.
And I am almost Dr. Matt, and welcome back to the Astroholic Live. And it's been a minute. I mean, it's been a good long minute.
It has been a good long minute.
When was it last that we were even live?
It was second week of March.
Second week of March. Good grief.
Yes.
And I bet you all missed us, and I bet you're all gagging for more of this.
And so why have you been so busy? Why have you been so busy? Publicize.
Publicize. Okay, well, if you insist. Wait, why have I been busy? I've been so busy I forgot why I've been busy. Because I am coordinating the Science Festival in Nottingham and trying to do my PhD at the same time, which I've learnt is no easy feat, but it's kind of fun. Hopefully it'll be worth it. So I'm going to plug this again at the end, but in the meantime, just to occupy your fingers while you wait for the drinks to start flowing, you can Google pintofscience.co.uk and check out your local city. And if you are based in Nottingham, great, check out Nottingham because that's my baby. That's what I've been doing. What about you? Well, your kind of busy has been a lot more fun than my kind of busy because you've been gallivanting all over the world, haven't you?
Yes, so I was in the States, I was in Italy, I ran a marathon, been prepping for the Shoutout Science Festival where I'm going to give a talk about smashing galaxies, and tonight I prepare us a drink. So, if you were following our Twitter conversation yesterday, I decided to have a molecular drink because I haven't get to do anything molecular for a while. And I thought, oh, we haven't had an Astroholic for 2 months. I need to celebrate, I need to make it special. So
we need to get turned up. It's been a while.
Yeah. So I thought, you know what would make it special? If we make a suspension sangria. So the idea is that you mix in the sangria xanthan gum, sorry, and you create a suspension. So your drink is not exactly liquid, but it's not exactly solid.
Right. What is it we've achieved? Sorry, I'm going to fix this because I'm falling apart at the seams here.
Well, we have achieved something, I would say, even better. People who are familiar with the work of H.G. Wells might have heard of the thermocalarite, which is this wonderful substance that is against gravity. So instead of having suspended sangria, I would claim that we have a calarite sangria. So
okay, this looks fun. Oh, now I'm thinking dessert.
Yes, and my jellification process was a success as a physicist because I didn't want a liquid. And is it a liquid? I don't think so.
But is it a solid? No, it's not.
It isn't. Well, so what we decided to have instead of our usual cocktail is a alcoholic dessert. So shall we have a spoonful to start, and then we start answering some questions?
Okay, but we still, even though it's not a classic drink, we should still toast to something.
Okay, so let's toast to...
Let's toast to being back.
Yes, to being back. Cheers.
Cheers, and I was almost about to try and drink it then, but obviously that doesn't work. What's this fruity stuff floating on the top?
So it's
apples. Wow, that's solid.
Apples on the top.
Mmm. Oh, Soren, non-Newtonian cocktails. Yes, indeed, non-Newtonian cocktails. That is weird.
Yes, and really alcoholic.
I can taste. Lord. So, just remind me, what have I just put in my mouth?
So I made a sangria. So it's white wine, a little bit of rum, and a little bit of orange juice. Just didn't want to put too much because it was supposed to be a suspension, so you should see the fruit. And then there's apples and strawberries. And surprising, the apples are all floating and the strawberries are all at the bottom. So it's like there is a sort of civil war. Which side do you take?
Oh, that's contentious. I thought you said we weren't going to get political, but I think this is something we maybe have to get political on before we get into the science. Captain America Civil War.
No, I was talking about, are you Team Apple or Team Strawberry?
Oh, no, I'm on a totally different thing. I don't care whether you're Team Apple or Team Strawberry.
Well, I'm Team Strawberry.
So, without any spoilers, are you Team Iron Man or Team Captain America?
Well, I went in as Team Captain, and we're actually going to discuss why I went in as a Team Captain. Matt will answer one of those questions. But the situation, it's a bit more complicated, but I cannot explain it without spoilers, so you tell me.
Tell me what I went in as.
Yes.
So, I went in, as always, to any Marvel movie, as Team Black Widow, and I officially came out Team Black Panther. So, that answers all your questions and none of them at the same time.
Perfect. So, let's...
First on the agenda.
First on the agenda, I would say we start with something that it's...
Did you hear that?
That
was a lovely squelch. Just what I wanted to hear. Sorry, continue.
We're going to start answering the question that our friend Duncan, who was our last guest...
Yes, he was. Shout out to Dr. Duncan Astle. What's his Twitter handle? Is
at Duncan Astle.
At Duncan Astle.
And yes, and so you see, Duncan, you not cursed us with your... because after we didn't do it for 2 months.
Yeah, and then... we thought it was going to be all downhill from there, especially after that 3-body problem, but don't you worry.
Yes,
we're back on track.
Yeah, surprisingly, Duncan started with, I have 3 related questions for you. You will be pleased to hear that none pertain to the 3-body problem. We like that. Anyway, question number 1. What is the reproducibility crisis? Does it affect all science or some disciplines more than others? So, the reproducibility crisis, and I'm very proud of myself to say it correctly twice.
I know, I'm impressed that you've gotten this far, especially since you started out not being able to say xanthan gum.
Yes, and I got a gold star, so I'm going to give myself a
gold
gold
well
star.
Done, yes.
It started with, I think if I remember correctly, with an article on Nature last summer, about the fact that a team tried to reproduce 100 psychological studies, and they found that about half of them, although they've been accepted and peer-reviewed and published in a very famous journal, about half of them cannot be reproduced. So their findings weren't actually correct, or at least the findings that they found was questionable.
And for those of you at home who are not entirely familiar about the importance of reproducibility, it's a big thing that basically the whole of science works on. Because anyone can come up with an idea, run an experiment, or do something and say, oh, this shows this because this. And then they say, oh, therefore I have proved my idea. But your idea is only really becomes fact and new knowledge if other people are able to do that as well, to confirm what you did and to prove what you did for you. And that's what's not happening in a lot of cases. Yeah,
so it's quite interesting. Duncan not only asked if it affects all sciences, then he went and asking if what are the causes and if we have a way to overcome it. So it's a fantastic discussion. I think we could have an open debate about it. It's fascinating. So let's think of a few causes. Actually, first, let's see, does it affect all sciences? I would say, in a very arrogant way, oh no, it doesn't affect physics. Wait before you respond.
Okay.
I'm not saying that it doesn't affect. So I think the issue are actually issue that affect every discipline. It comes from every discipline. The reason why it might affect physics or no, just physics and all the disciplines less, but not physics not excluded. It's the fact that we put a higher standard for the discovery, for when we find new science. To something to be proven in, for example, particle physics, a signal needs to have a certainty of, you need to be sure that your signal is not a fluke, with this 5 sigma that you might have heard. Is a sort of golden rule. It means that your certainty is the idea that all the signal you get is a fluke needs to be less than 1 in 3,500,000 chances. So it's...
And that's pretty darn... Like, that's like pretty slim. That's like, you've got to really push your error, margin of error, like way down.
This is why we are forced to keep pushing. That doesn't mean that we don't get claims, but usually we, at least physicists, tend to be a lot more skeptical, in the sense that we don't trust each other. So if somebody say, "Ooh, I found this," and you're like, "Oh, what is your sigma?" Say, "Oh, it's for 4.9 sigma." Say, "But it's not 5." And for example, you find things that are great, like the first signal from the Higgs boson was found as 100. There was one at the correct 125 giga electron volt value, but there was also one at 2.8 sigma that is more than 99.99% certainty at 140. And then when they got more data, the signal disappeared. So it was a fluke. Obviously, you cannot have the same in the medical, biological science, and maths will explain why. But it's, although I can be all arrogant and say, it's for the science they are less pure, it would be lying. It's, well, not lying, but the causes are that create this reproducibility crisis. It's common throughout academia. Matt, if you want to discuss why it's a problem more in the...
Am I allowed to defend the non-pure sciences now?
Not
okay,
pure, less pure. Come on.
Okay. When it comes to non-physics sciences, and this is mainly life sciences, things like biology, chemistry, medical studies, things involving, mostly things relating to living organisms, we don't use the same system of scrutiny that physics does in terms of trying to make our results match up to this 5 sigma level of, I don't know what you'd call it, or level of correctness maybe?
Certainty.
Level of certainty. What we use is we use the p-value as a standard. So, and that's because when in biological sciences there are so many variables in any given experiment that if you were to account for all of them and a large amount of them being unknown, especially in living systems, so if you test something in humans, for example, and you get a bunch, say 3 humans, and you get them to tell you, oh, what is this, does this colour change from blue to green or green to blue kind of thing? Mm-hmm. Give them a question like that. You could get 3 different answers, or you can get 3 same answers. And you keep asking the same question again, and you could keep getting a different answer. That's because no 2 of those organisms, i.e. the humans, are the same. And it's when you start scaling that down into smaller scale experiments in maybe animal models or in cell culture models, and even not using any sort of living models as well, there's still so many factors to take into account. So we use the statistical p-value, and so if anything is more than p 0.05, then we don't consider that significant. So you do see sometimes we see papers where they say, oh, well, look at this data, we got like a nice pretty line, which looks like a nice trend because it's p equals 0.04. We're like, wait, 0.06. You're like, okay, that's great, and yeah, you can say that's a trend, or you can say that, oh, it's absolutely nothing because it's still not significant.
See, it's the p-value, in the same way as the 5 sigma, is completely arbitrary. It's a limit that science put on itself. Our issue here is that science it's a poor description of reality, and yet is the best description of reality that we have. So we are stuck in trying to make the best of what we can understand of the world and make it simple enough for us to continue and push our limits. The problem with the reproducibility crisis,
and we lost it.
And here's my
it wasn't even 3 times. Don't you worry, I'll take it from here. So the problem with the oh my god, I can't even do it!
I'm back.
I'm done. I'm done.
The problem
is... It's this. I blame this.
The problem is it's coming from academia. There is this push of publish or perish. Scientists need to get ahead in academia. They need to publish as much as possible in the most prestigious journals. That's how you get your next postdoc. This is how you get your tenure position. So it's better to have a flashy result saying, "Oh, I tried this, it's brand new, nobody has ever done this before, and I got this result. It's valid," rather than say, "Oh, I just went and checked those results." So it's creating a sort of bias towards the more flashy result. If you need to publish as much as possible in big journal, you don't have time to go and test again claims. So outlandish claims get tested, but if people think, "Oh, that's probably true," for example, if you put a lot of agar-agar into hot sangria and then you put it in the fridge, you'll form a jelly. But would you form a suspension? It's like, oh, you should form a suspension, and then you put it in the fridge and you don't check for 8 hours, and then you come and you check how the suspension is coming along, and you find that it's jelly. But maybe you're just like, "Oh, I think it's going to form a suspension." You write your paper, and it's like, there is a 95% chance that you formulate a suspension, and people check it like, it makes sense. Agar-agar could create a suspension. But then somebody else is like, "But no, agar-agar is quite a jellification agent, especially if you put it in the fridge, it will form a jelly. Who is this idiot? Why does he know any chemistry?" That's probably because he's a physicist doing chemistry.
And agar metaphors aside, the main problem with this publish or perish culture is that it means so many scientists end up only publishing data which is, as Alf said, super flashy and tells a really amazing story, and then all the data that is negative, because very often people will follow ideas in science, and it happens all the time, and it's a good thing, where you follow an idea down a path to see, okay, is this true? And you realize it's not, and you have negative results. And the fact that nobody wants to publish negative results. There is a journal of negative results, but there's still such a stigma around, "Oh, we got negative results, forget it, put it in the bin." And that means there's so much data that's been generated over the years, even decades or longer, that has shown that this doesn't work or that doesn't work. That's not included in our sphere of knowledge now. But on top of that as well, because people are trying to sell the flashiest part of their story almost, and by their story I mean when people write their papers, they're going to lay out what they've done, why it's what they found out and why it's important. But with all the emphasis being on the story part, there's so much neglect that's gone into the methods basically, and people have done studies and meta-analysis of other studies that have shown that so many, I'm speaking from a life science point of view, so many methodologies in papers are completely unreproducible because there's just not enough detail in there because everyone's going for the flashy.
Also, if we don't have negative results, we don't know which path are actually cul-de-sacs.
Exactly. But on
No.
that
Last.
last, oh wait, we've got the last point.
Yeah, last point is how do we fix this? So we need a good overhaul of publication industry, because it's an industry, it's for profit. Overall of how academics and how get their job and how they advance in their career. And I think, talking as a science communicator, I think there's also some responsibility on us. Obviously, we are for profit, so you want to publish the newest result, the most interesting research, and no shy, even the weirdest stuff. We publish about this week about genetically engineered gay super beetles, because there is a
I'd
push.
watch that movie. I'd watch that movie.
Yeah, there is a push to trying to understand if sexuality in animals is genetic, epigenetic, what are the consequences. It's weird, it's weird research, and you're probably gonna get more clicks and more links on my very carefully crafted article on pretty galaxies. But we are for profit. You need the cool, weird science as well as the hardcore astrophysics. So something that we actually discussed in the internal meeting a few weeks back was actually that we should look at the big medical stories of the year at the end of the year, and actually try and follow up in if there's been more research on that, if it's been just one claim and then it disappear. And if we actually do this, I think it's going to be quite something. If we, even if just contacted the researcher, say, okay, you did that 1, 2, 6, 10 months ago. Where are you now? What are you doing? Are you doing follow-up? Are you gonna keep testing this? And we have a good, a large audience, so maybe we can make a difference. Other than that, I think, unfortunately, being outside of academia, it's beyond my power. But I feel that is a struggle that needs to be fought by everyone who's in academia.
Well, we can only hope that some difference is made somewhere along the line, and we can all just strive to be a little bit more rigorous in our science and how we go about telling everyone else what we've done. And yeah, but let's move to a slightly more positive note, shall we? And talk about some of this flashy science that has been done. So you've had some good stuff happening in the world of astrophysics lately, haven't you?
Well, in a small corner of astrophysics that now has taken over everything. Apparently, it's exoplanets.
What is an exoplanet? I mean, and why is it such a big deal? Tell us. I don't know why my voice is going like that.
The exoplanet is a planet that orbits a different star. Seriously, you had one spoonful.
I'm not blaming the alcohol content. I'm blaming the weirdness of whatever this is. I mean, it's solid wine. Why is the wine solid? I feel like I'm having a Jack Sparrow moment of why is the rum gone, but it's why is the wine solid.
We're spicing things up. Anyway, Kepler has confirmed 1,287 new exoplanets, pushing the total to past 2,000 towards 3,000, and it's just like there are more exoplanets that we can quickly remember, or at least I can quickly remember, and it's fantastic because it's telling us that the universe is bigger and weirder. We actually, most people were expecting to have that the big news was that exoplanets are incredibly common. We found enough statistical evidence that says that every star has a planet. But we're not there yet. We suspect that to be true or to be very close to the truth. But we're still working on that. But what we found out is there is such a diversity, such a complexity in star system, and yet our solar system is still quite unique because we haven't seen the configuration yet. But our technique might to spot exoplanets might not be ideal. To look at system like.
And what do you mean by our configuration that you've not spotted yet in other?
Well, we have
systems?
4 rocky planets moderately close to our star, and then we have 4 giant planets quite far away, and then we have a phenomenal array of smaller bodies which are the dwarf planets in the Kuiper belt, and I'm sure there's going to be, maybe there's even a 9th planet which had just been announced in the last Astroholic.
Nibiru Planet X is going to hit us, we're all going to die. Is the results you would get if you were to Google Planet 9, unfortunately, before you actually get to the articles that tell you about what Planet 9 could be. So, just warning you, Google it with caution.
Yes, you can Google with Planet 9 Mike Brown, who is the researcher that worked on it, or just put my name, some article will appear. What's interesting is also we might actually have a mathematical solution for what happened to our solar system. Why is our solar system special? There is a system called Kepler-223, which is fantastic. You have a configuration of 4 planets orbiting very close to their star. I think the closest has an orbital period of 7 days. So it goes around the star in a week. And the furthest is got an orbital period of 19 days. So almost 3 weeks. But fantastically, they are in resonance. So the ratio of the orbital period is an integer number.
Okay.
Well, I'll explain what it is.
Okay, I'm going to let you finish. I won't go Kanye on you, so you carry on.
So, have you ever seen the trick with having 2...
2 fingers, got them?
No, not the 2 fingers. The timekeeper that you use on pianos, and I completely forgot.
The metronome.
Metronomes, and it's the same word in
I think we should
Italian.
start a new game here. Tweet in if you know the word that Dr. Carbonetti is trying to say before he actually says it.
If you put 2 metronomes on an elastic surface, or something that can transmit momentum, and you start them at a different time, they will eventually synchronize.
Interesting.
And that could happen even with planets or satellites. For example, the Jovian satellite, Io, Europa, and open is Ganymede. I always forget if it's Ganymede or Callisto. It actually they're in resonance. So when in the system that we're considering, this Kepler-223, when the first planet does, let's assume the first planet starts, it does 3 loops and it goes back to the same point that the fourth planet, that the second planet does in 4 times. So every time this does 3 times and this does 4 times, they're back to the same point. Okay. And then when the third planet is every 6 times and the fourth planet is every 8 times. And it's precise. It's the most precise system, and it's a very old system. The star is about 6 billion years old, and it's very, very well balanced. It's a perfect cosmic ballet. But surprisingly, if you
beautiful.
If you put everything in a simulation, you just need a little bit of disturbance. Small planets, big asteroids messing things up, and the entire system just crumbled. You have still the planets, but they're not in resonance anymore. So the question is, what has happened in the early solar system? They think that the presence of so much matter that eventually form Mercury, Venus, Mars, Earth, the asteroid belt, has broken the resonance between the 4 giant planets. And without the resonance, the planets were not able to move towards the star. So that is another fascinating thing. And the last things about exoplanet, because I realized I've been talking a lot, is we found the 3 closest exoplanet to Earth, and it's closest in terms of size, but also quite close in terms of distance. They're about 39 light years away, and all 3 of them.
Again, light years is not a measure of time.
Yes, it's a measure of distance.
Exactly, the distance that light takes to travel in 1 year.
Same goes with parsec. Anyway, they are either very close or just on the edge of the habitable zone, and they are around a very small red star. And the type of stars is one of the most common type of stars in our galaxy. It's telling us that planets, Earth-like planets, in habitable zone could be incredibly abundant in the universe. So I think that is fascinating and
super exciting.
Super exciting story.
Because they're finding so many more new ones. It kind of feels like it's only a matter of time before they find some really interesting candidates to try and explore further. We got a quick message on Twitter, well, a little shout out on the back of our negative results
reproducibility crisis. Yes,
you messed it up for me. I was doing fine with this until you
I'm getting back my gold star.
Anyway, Soren C. Sterling, who's on Twitter as @SorenSterling, just wants to let us know that Tesco Ginger Beer and Mystery Brand Whiskey is a negative result. So thanks, Soren. It's good to know. You see, now Soren has published his negative result. We know that in future we will not be mixing Tesco Ginger Beer and Mystery Brand Whiskey. You see, it works already.
Exactly.
Bam, crisis solved. You're welcome.
Okay.
Mic drop.
So, if we go back to our questions...
we had another one, did we?
We did have another one, and it's a fun one. So,
ooh, I like fun questions. So, go on, who's this from?
So, this is from... Sorry, I lost that.
This is no time for Angry Birds, come on.
No. It's from Gay Lucite. It's me,
I got this. Gay Lucite. Okay, wait,
yeah.
No, I don't know that either. Gay Lucite.
Yes, it's me, Earl. He asks, scientifically, why are men's butts so nice? And he continues with, I want 3D surface analysis and everything. It's all about the dips you get with bigger glutes. So, first is, I found this a little bit sexist, because there are women with just lovely buttocks.
So, hold on, let's just recap here. The question is, and this is the first time I'm hearing about this, why are butts so nice? Well, you've made it why butts so nice from our Twitter.
Yeah.
Twitter person.
So let's just talk. Since I thought you might be an expert. Because
now, why would you think?
Because it's life science. Why are
okay?
Seriously,
Butts.
why are people so fascinated by good backside?
I'm not gonna lie, I have no idea. There's several good little tidbits of information, little facts I know about sexual attraction in general. But when it comes to butts, I've honestly never read anything about that. I mean, it's just one of those kind of givens that we just know that people like butts.
Okay, so we are in completely virgin territory. And you wish you had the shame bell now.
Yeah, I wish I had the shame bell, but unfortunately my shame bell device is currently streaming us on Periscope. Hey Periscope, how you doing?
So,
do we have a question?
I have a theory.
We have a theory from producer Chris. Go ahead, Chris. What's yours?
It's completely evolutionary. Look at apes and things like gibbons and primates who show off sexual attraction by having massive butts.
Interesting. Okay, so that is a very interesting theory, and it's brought back a little memory for me. First of all, if you're just joining us now, welcome to the Astroholic Live. We're discussing butts. Please send in all your comments, queries, theories about why people find butts so damn attractive. But an interesting thing, an extension on that theory might be that because if you look at humans compared to other apes, we look very significantly different in terms of between our sexes.
Is it because we are erect?
Oh, that hurt to listen to. That hurt to listen to. But no, it is not because we are erect, and by erect,
No, erect I meant standing up.
Yes, I know what you mean, but I also know what you also meant. Like, but if you, that's not a pun, by the way. Excuse the pun. But wait, no, don't excuse the pun. You're making me distracted now. So humans for millennia have evolved to be so sexually dimorphic, which means that the males and females look differently, because humans have bred with sexual selection in mind, which means males have chosen females to copulate with who have certain physical characteristics that they deem sexually attractive, and the same for females in males. And this has led to human females having larger breasts than any other ape species. But for example, in gorillas, it's also something that has likely led to the fact that male gorillas are enormous in comparison to female gorillas, and they also have slightly different body shape you would expect. Whereas you don't see the same kind of sexual selection in chimpanzees, because they kind of all look the same. So going on what producer Chris says as a potential theory, that he just threw out at us, that was something about like, is it because apes like to show their butts at each other?
Yeah.
Something evolution, something butts. Who knows? Yes, it could be entirely possible because we are a very sex-orientated species. And let me just see if anyone else is joining that conversation, because I mean, I would gladly welcome some theories on that. But it is slightly related to my next talking point.
I would suggest, simply because when did we start copulating?
When did we start copulating? Well,
facing each other.
Facing
each other, instead of in a more doggy style.
Okay, now we're getting into super vague territory, because animals do it so many which ways.
Yeah, but could it be that, I don't know, I'm a physicist, I'm trying to solve a problem. Could it be that we got, could it be that it's something that we just fancy and just evolutionary because we were showing it more?
Well, all I'm going to say is that yes, if you got it, do flaunt it. But seeing as we are delving into the realms of complete speculation here, I suggest we leave it to the audience to tell us what the fuck we should be
Suggest
thinking about this. Seriously, send us your theories. We'd be super interested to see them. And if you send them to us, we're definitely going to start discussing those. Somebody has tweeted us a link, and I'm sorry, but because of our current topic of conversation, I'm not going to click that link, because we are live, and there might be children watching. I hope there's not.
No, there are not. Anyway, why don't we move on to your...
Yeah, so staying on the topic of sex, recently there was a study published entitled, again, here's another example of the flashy bit of the science. It was entitled Wired for Sex, speaking of the brain and its wirings. And what the study involved is looking at differences in something called synaptic pruning between males and females. And what they found was that, so first of all, synaptic pruning. So everyone has you probably know that you have all these neurons in your brain, which are little cells that face each other like this, and they send out little chemical messages across this little gap to talk to each other. But as we develop as humans, not only do we make these connections, but the brain will also break a few, and that's called synaptic pruning. And that's a lot of that takes place as well when you're a teenager, because your brain is effectively rewiring itself in response to all the hormones going through your body through puberty. So anyway, they looked at this process in C. elegans, Canorhabditis elegans, and this is a nematode worm, which is widely used in neurosciences as a model organism, which is great, and it's super interesting that they found that the pattern of synaptic pruning is different, and it seems sex-dependent in males and females, and yes, these worms do have sexes. But there was a couple of news stories where this paper and this study were reported in local media, And of course, they neglected completely that the whole study was done in nematode worms, microscopic nematode worms, which are, by the way, an absolute ball ache to count under the microscope. Not that I did that for 6 months. But of course, it was reported as male and female brains rewire differently. And people try to use it to run with the whole male and female brain idea, which is slowly and surely starting to be disproved and thrown into
there's actually been a study on
major
humans
uncertainty.
that showed that there's no difference. So.
Yes, and we've actually had a couple of comments on our butt talk. So, first of all, what have we got here? So, Dr. Ben Britton at BMatB. Hey Ben, how's it going? I'm not sure what you're watching on, so I don't know which camera to look at. He said could be related to attractive lumbar curvature, and he's linked us to a paper.
Yes, I'm going to retweet that.
Yes, super interesting. Also, lumbar curvature. That's made me remember something. There is several studies that were quote cited in some reviews in literature to do with sexuality, sexual preferences in mammals, and there is when the curvature of your spine is so that your bum sticks out more. That kind of people have found links between that and the way you stand in with your spine and your sexuality, i.e. People who prefer and animals that prefer male partners tend to apparently have its more sticking out. This is, by the way, it was completely refuted, but it was a really interesting thing to read until I got to the end and was like, okay, so wait, you're saying that people whose butts stick out more because their spine is, the lower part of their spine is curved more, like male partners because they're kind of sticking their butts out to them? And then I got to the end and I was like, okay, this can't be true, why am I reading this? And then I realised it was just thrown in there because it was an interesting story, which I thought I'd share now. But
so you see the problem with academia.
Yeah, academia. They find an interesting line of. Oh my god, we are totally dragging our own industry and way of life through the dirt tonight. But that's what science is about, you know. No one is immune from criticism, including us and science and all that jazz.
Yeah, this is why I was quite upfront about how do science communication cannot only be hardcore science. Since we can move from bots, I have a question from Lee earlier that he asked me about this interesting paper that looked at time travel. He wasn't too happy because it kept proving that time travel it's not possible as we think time travel should be possible. So the article said the science communication article was just like physicists send particles of light into the past, proving time travel is possible. Did they? So they had a photon interacting with its past self in the closest thing that we can create to a grandfather paradox. The grandfather paradox is when you build a time machine, you go back in time, and you kill your grandfather before he can father your father.
So it's not like the one in Futurama where he goes back and he becomes his own grandfather. Is that on the same level? That
is the Futurama played on the concept in a very, very hilarious way. Is the fact that the universe that tells us that either the universe is deterministic, in which if you go back in time and kill your grandfather, then you will never be born, so you cannot go back in time and kill your grandfather. Or the universe is completely random, so you go back in time and you change things in a completely weird way. The problem is that us planets, galaxies, tables, rabbits are not. We're not governed by the laws of quantum mechanics, or just indirectly. So you can create a quantum system which has a photon that only interacts with its past self. Or in the same way, you can see you have a photon that only interacts with its future self. In a more interesting way, well, in a more, not correct, but in a more simpler way to understand it. So this interaction can affect the past and the future, but only for that specific photon, and only in a determinate, in a probabilistic way that you can calculate. It's like saying, if you could actually go back in time, you only had like 50% chance of killing your grandfather, and the universe not gonna care if you do. That's how things work. But you're creating a system in which the system that they created is fascinating because it's a system in which you started by having the time traveling part being correct. So you have the interaction between you and your grandfather. So imagine if you have a universe in which you're saying, okay, the time machine works and you're going to meet your grandfather. There are going to be universes in which the grandfather defends himself or he doesn't die, and there are universes in which you actually kill him. But the interaction is planned. You're going to meet him. So it completely is not that time travel is possible. It's we can change, we can interact with the past in a quantum way. If that can be taken into our non-quantum world, that's very, very interesting. I can build my own TARDIS and everything, but so far our world is governed by relativity more than quantum mechanics. So we'll have to say that fortunately nothing can travel faster than the speed of light, and time travel is still not impossible, but unlikely, as far as we can tell.
Okay.
So that was my long-winded answer. I have another small question to answer, but
to round that off, if you're still as confused as me, just look out for the inevitable movie that will be out in the next couple of years, butchering this concept, but in such a way that people like you and me might be able to understand it. Because that...
Was that too complicated?
So basically, not what you said, but what they said. I just don't get. I just start talking about like past and future selves of a photon. I mean, is a photon even really there? Anyway, we're gonna go. I would go off on a massive tangent there, and by tangent I mean like a horrible dark well of sadness where I realise I have no concept of understanding physics. But that's why you're here,
yes,
to explain that to all of us. Although hearing that kind of made me wish I could sip this because it made me feel like I didn't drink. Because knowing people like that are out there trying to mess with that.
Just keep spooning.
Just keep spooning. On that note, you said you had another question?
I have another question, but I'm happy for you to answer something.
We got a... well, I will be answering something, because we did get a question through, which is great. We also got a shout out from previous guest and all-round loved heartthrob, Dr. Duncan Astor. He says he's enjoying the show from just after having some Thai food, and now I'm extremely jealous and hungry. So, hey Duncan.
Have your jelly. You see, it's both drink and dinner and a show.
Anyway, I got a request from at Blackfinch, which is Dan. Hey Dan. He says, could you tell us about the significance of the first eukaryotes found that don't have mitochondria? Wow, let's start that again. Could you tell us about the significance of the first eukaryotic organism that was found to exist without mitochondria? Okay, Dan. I'm going to answer your question. Hopefully better than I said your question. So, this news...
Okay, imagine that I know nothing about what is a eukaryote, what is a mitochondria.
Don't worry, my dear, I'm already imagining that. That's what I imagine every time I talk to you. That you just know nothing about what I'm talking about.
I throw this drink in your face.
I assume you do the same. I assume you do the same. We work on totally different levels. Anywho, so a group have recently published a paper about the discovery of an interesting little critter that was found inside the gut of a chinchilla belonging to one of the members of the lab. Ooh, I know, right? Also, I'd love to go and speak to them and know the story of like why they ended up cutting up their pet chinchilla and like digging into its organisms. Or whatever.
They didn't cut. Okay, no chinchilla was harmed.
Oh, I'm assuming it died and then they.
No.
Or
it was in the intestine. They actually just took a stool sample. I'm assuming they didn't have anything else to do that day.
Okay.
I'm not
Okay, disclaimer, I didn't read the part about what they did to the chinchilla, partly because I didn't really want to know, but I'm sure it was fascinating. But anyway, they found a little single-cell organism living inside the gut of this chinchilla that doesn't have mitochondria. And I bet you're all at home thinking, WTF is a mitochondria? Well, I'm going to tell you, a mitochondria is an extremely important and crucial part of all up till now, all eukaryotic cells. It's a tiny little kidney bean shaped organelle, which means it's a tiny little, it's like an organ, but on cells, on the scale of a cell, so we call it organelle because it's tiny. And what it effectively does is it makes energy for your cell to survive. Eukaryotes, by the way, are one of two main classes of living things on our planet. We have prokaryotes and eukaryotes. Eukaryotes are what we are, and that just means we're made up of cells that have all their DNA inside a membrane called the nucleus, and they also have other little machinery inside their cell compartmentalized in nice little membranes, like a mitochondria. So evolutionary theorists have been studying like how we got the mitochondria incorporated into the part of the eukaryotic cell for decades, and it's widely believed that at some point, billions of years ago, a symbiotic relationship was formed between highly energy-intensive bacteria, like organism, and other larger single-cell organisms, i.e. one going into the other, and then they kind of help each other survive. But in these larger organisms, like us, it's extremely important for us to have these mitochondria so that we can actually live, because they make energy for us. So it's really fascinating to find a eukaryotic organism that bucks the whole trend. And the interesting thing is, not that it evolved, so their study suggests that this little gut parasite type thing the gut microbe. I shouldn't say parasite, that was the wrong use of the word.
Yeah,
this gut microbe.
I think it's symbiont.
Symbiont, yes. So this gut microbe didn't evolve without its mitochondria, but in fact it lost its mitochondria, which is even more fascinating because that means that this organism has obviously found a niche that's so well suited to, and then obviously provides with all the nutrients and energy that it already needs, that it no longer needs the little part of itself that is required to make energy. And that's really, really quite fascinating because mitochondrial disease is a very big, it's very, very serious if humans have it. There's obviously something wrong with your mitochondria, something wrong with every cell in your body which contains mitochondria, which is all your cells. Spoiler alert. So it'd be super interesting to see what else they find out about this little creature, if and when they look into it more, which I hope they do. And yeah, I do want to kind of know now what happened to the chinchilla.
I think I don't think anything happened to the chinchilla. So I have a.
I hope that answers your question, Dan. I hope I didn't just butcher it like I butchered the actual question.
So you have a.
Dr. Ben Britton has given us an update on the whole butts and spine curvature paper. Apparently, he says, apparently the page says, men can tell the difference between big butts and prefer a great spine. Hashtag who could be spineless. Make your own conclusions.
Yes. So I have a question. It was posed to me by Justin. His Twitter handle is J.E. Beckman, and it was why is astronomy important? It didn't mean in astronomy.
Good question. Defend yourself. Why is astronomy important?
Yeah, he gave me. We had a wonderful conversation. Obviously, he was playing the devil's advocate on. Why is astronomy important? And say, oh, we can do. There's more important things to do on Earth. Astronomy is great. You have amazing pictures, but isn't it a little bit like a fairy tale that is all far away? You cannot touch it, you cannot reach it. So it's true. All of us, we are we're never going to see the stars, or it's unlikely. We're never going to travel to space-time or to a galaxy far, far away. But astronomy has been probably the first science. We needed to plant the crops, then we used it for religious purposes and for civil purposes. Our calendars, our concept season, birthdays, everything is deeply based in astronomy. And now is, I would say, as an incredibly arrogant person, is the thing that makes us humble. Astronomy reminds us of our place in the universe. It tells us that we are tiny and small and absolutely insignificant. And
I agree.
And yet, although we are absolutely tiny, we are a speck of carbon or a speck of silicon orbiting a banal yellow star in, to quote Douglas Adams, the unfashionable arm of the Milky Way, which is just an okay galaxy, nothing special about it. And yet, we are monkeys that should be in the savannah just scavenging. And yet, we can do maths, which is the way that we can understand the universe. We can imagine things, we can abstract, which is the fundamental of both art and science. We are able to see the universe as it is. We are able to see how the universe could be. We are the universe
understanding itself. We are.
And it's fascinating because that makes us humble and insignificant towards the universe, but also give us a responsibility. Our responsibility is to understand the universe. Our responsibility is to protect the universe and all the wonderful life that we have on Earth. So we need to feel both humble and big responsibility. With great powers comes great responsibility, and this is mission. This is why astronomy is important. It reminds us of our place in the cosmos, and that place, it's an in between the huge and complex and the tiny and precious.
So to recap, space big, space cool, humans tiny, humans need to be more humble.
And humans need to be a bit better.
A bit better. But can't we all be a bit better?
Imagine if we can all be a little bit better.
I can imagine some ways. Yeah, I mean, I'm pretty sure I would be more than a bit better if I could fly. But that's not quite the thing you're thinking of.
No.
I know, but still, it would be great.
Alright, I think we just reached 1 hour, which is exactly what we set up to do today. So, sorry about the technical difficulties. We'll try our best next time.
If you were watching through the YouTube stream, please let us know if it was
Dan told us that it was alright.
great, but you know, and more than one is always welcome.
Yeah. And yes, the next one is going to be in about 5 weeks' time. You will find out when and what we're going to talk about in due course. But send us your question if you have them. I was, actually I still am.
You was in it.
I was Doctor of Procrastinating, with that what I'm trying to say, but I also am the Doctor of Procrastinating.
No, you were Dr. Calvinetti. Anyway, yes, sorry, I was getting hung up on a grammatical point. But thank you very much, everyone at home, for watching this
Thank
ridiculousness.
And see you soon.
Thanks. And I'm sorry I didn't eat all of your thing. I just